Hello, welcome to Unit 5, Lessons 4, Understanding Decay. The learning objectives for this lesson is to be able to use only multiplication to represent decreasing a quantity by a fraction of itself, to write an expression or equation to represent a quantity that decays exponentially, and to know the meaning of exponential growth and exponential decay. Just a reminder that you need to make sure you fill everything out as I fill it out, and you will be expected to submit this for points. If you do not submit this for points, you will not be able to move on to the cool down until it has been submitted. We are going to skip the first activity, so you can just go ahead and cross that out, and we're going to move on to the second one. So for the second activity, I'm going to pose this question to you. If Diego has $100 and spends a fourth of it, how much does he have left? So one way to look at this is to look at how this person went about solving it. So there are 4 different steps. So go ahead, pause the video, and explain what's happening in each of the 4 steps. All right, so in step 1, they are taking the difference. So this is the difference between 100 and 1/4 of 100. So we can see that we have 100 minus 1/4 times 100. Step 2, they applied, so we are apply the distributive property right? So we can see that's how it's written, is as a distributive property problem, or you could even think of it as factoring out 100. Okay, step 3, we can see that they replaced, so we replace the 1 minus 1/4 with 3/4, right? Because we know 1 minus 1/4 is 3/4. And then the final step, they are applying. So we apply the commutative property of multiplication. So just remember, commutative property tells us that we can multiply in any order. So what they did was they just moved the 3/4 from the back to the front. So let's take a closer look at this problem. So if we know that Diego is spending a fourth of $100 and we want to try to figure out how much he has left, we have to first take a fourth of 100 and then subtract that amount from 100. You can also rewrite that as 3/4 of 100. Think of it as kind of similar to like a percent increase or decrease, right? He's spending 25% of $100. So if we want to know how much he has left, we're going to subtract that amount from $100, or you can just think of as we will have 75% left, so 75% of 100. So using an idea of figuring out how much is left, for question 2, it says a person makes $1,800 per month, but a third of that amount goes to her rent. What 2 numbers can you multiply to figure out how much she has after paying her rent? So essentially we're asking how much does she have left? Go ahead, pause the video, and see if you can come up with what you're going to be multiplying. So if a third is going towards the rent, that means she has 2/3 left. And she's going to be taking that 2/3 and multiplying it by the 1,800. So those are the 2 things you're going to multiply. Don't need to actually answer the question, just needed to see what to multiply by. So now it says write an expression that uses only multiplication, and that is equivalent to x reduced by 1/8 of x. So go ahead, pause the video, and answer this question. All right, so if we're doing x reduced, so that's subtraction, by 1/8 of an x, essentially, we're doing 1x minus 1/8 x. Well, 1 minus 1/8 is 7/8. So our expression would just be 7/8 x. Now, why is this important? Because we could just do subtraction and we could figure out what everything equals that way. But when we are looking at exponential situations, we are looking for something called the common factor. So what is that number being multiplied by? This common factor does play a role in how we graph and in how we solve, and also just makes it a little bit easier to solve quicker. Rather than doing x minus the fraction of x, we could just take a fraction of x. So keep in mind that sometimes there is that idea of subtracting, especially when we're dealing with decay problems. So you want to make sure that you figure out what that common factor is. So in this case, for this specific problem, 7/8 would be the common factor. All right, let's take a look at the next activity. So it says every year after a new car is purchased, it loses 1/3 of its value. Let's say that a new car costs $18,000. So what you need to do is go through and answer the 5 questions on this activity. So pause the video and go from there. All right. So question 1 says a buyer worries the car will be worth nothing in the next 3 years. Do you agree and explain why? So for this one, I would say disagree, right? And if we think about it, regardless, if the car loses 1/3 of its value every year, it's never going to reach the value of 0. Even so, after 3 years, it's not going to even be close to 0. It will be significantly less, but it's not going to ever reach 0. You're going to always be multiplying by a fraction, and the only way that something can reach 0 through multiplication is if you're multiplying by 0. So it's never going to actually reach 0. It will never, and we'll say technically, reach 0. Because obviously, a dealership may say, well, I'm not going to give you anything for that car. But technically, if we're using this idea that it's losing 1/3 of its value, it will never technically be worth $0. It may get smaller and smaller and smaller, but it'll never get to 0. Let's look at question 2. So it says, write an expression to show how to find the value of a car for each year listed in the table. So when they purchase the car, that's going to be year 0, and that's $18,000. For after 1 year, if it loses 1/3, that means it's going to be worth 2/3. So we're going to be doing 18,000 times 2/3. After the second year, you take the previous year, which would be 18,000 times 2/3, and then we're going to multiply by another 2/3. Year 3, you're going to be multiplying by 2/3 3 times. Year 6, you guess it, you're going to be multiplying it by 2/3 6 times, but instead of writing 2/3 6 times, I'm just going to write it as 2/3 to the 6th power. So any given year, I would calculate that by doing 18,000 times 2/3 to whatever year, so to t years. The key thing to remember here is that we're not multiplying by 1/3, because that would just tell us how much it decreases. We're multiplying by 2/3 because that's the actual value of the car. So keep that in mind. Question 3 says to write an equation relating the value of the car in dollars V to the number of years T. So we're going to take that expression for our last entry and just set it equal to V. So V is equal to 18,000 times 2/3 to the T power. And then last but not least, it says use your equation to find V when T is 0. What does this mean? So last lesson we talked about what happens when you raise a number to the 0 power. Well, we know that anything raised to the 0 power is just equal to 1. So we're just doing 18,000 times 1, which is 18,000. So this is going to be our price when the car is purchased. So that's question 4. Let's look at question 5. Now, a different car loses its value at a different rate. The value of this different car in dollars is D after T years, can be represented by the equation D equals 10,000 times 4/5 to the T power. Explain what the 10,000 and the 4/5 mean in this situation. So the 10,000, that's pretty obvious. That's just the price of the car when it's purchased. So the initial cost of the car is the initial cost of the car. And then 4/5 tells us that the price is decreasing by a factor of 4/5. The price is decreasing by a factor of 4/5 each year. So we can say by decreasing by a factor, right? Because each time we're multiplying by that same factor. Its overall value, though, is decreasing by 1/5. Because it loses 1/5 of its value, but the total value is decreasing by a factor of 4/5. So the current value is decreasing by a factor of 4/5. So it loses 1/5 of its value each year. It's decreasing by a factor of 4/5 each year. So in previous lessons, we talked about this idea of a growth factor, right? It's the number, the base basically, that is being raised to some exponential power. We were focusing more on exponential growth when we were talking about this. These problems are not growing now. They are now decreasing. And as I mentioned earlier, we call that exponential decay. This in general, this is still called the growth factor, even though it's not technically growing. It's decreasing, but we still reference it as the growth factor. Or you could even just say decay factor if that helps you. But you can still call it growth factor even though this number is less than 1. It just tells us that the result is going to decrease with every iteration. So every year we are going to see a decrease, and we know that because the growth factor is less than 1. If it's helpful for you, you can call it decay factor if you like, but that's really, it can go either way. Now, some other things to keep in mind that to help us, especially with this table problem, to remember that we're multiplying by 2/3. You could potentially write this as subtraction, right? So I'm going to change my color here. You could write this as 18,000 minus 1/3 times 18,000. And that will essentially get you the same value. But what happens is that as we continue to go in years, we're going to have to keep multiplying and keep writing the subtraction. And so it just gets a little messy when we do it this way. So that's why we try to avoid the subtraction way, and we focus on just figuring out what that growth factor is or decay factor and writing it in a more simpler term. So in this lesson, we looked at quantities that decrease or decay by the same factor repeatedly. So we looked at these problems that are called exponential decay. These are a little bit different than what we've talked about before. Helps if I can spell it, exponential decay. We've mainly looked at exponential growth, but now we're kind of taking in this idea that some things do decay, especially when you're talking about resale. Cars, for example, are one item that as soon as you purchase it, the value goes down tremendously. Other things, it could be something like a camera that would show decay. And then even sometimes, depending on the housing market, sometimes your housing could show some decay. I would say for the most part, usually it's more of an exponential growth, but there is these other ideas of exponential decay. So let's suppose that we had a digital camera, I'm gonna go down a little, that was initially worth $400, and it loses a third of its value each year. So the key thing to remember here is that the decay factor or the growth factor is not 1/3. It's actually going to be 2/3, because we're talking about how much is the camera currently worth? What is its current value? If it loses a third of its value, that means that it is currently worth 2/3 of its value. It is still going to be decreasing by this growth factor of 2/3, but we're not going to be using 1/3. Our equation or expression that would help us figure out what the camera is worth is we're going to take that initial value of the camera, multiply it by the growth factor raised to whatever power. So if you wanted to figure out 5 years, you could raise it to the 5th power. So keep that in mind. A very common mistake is that students will use the 1/3 instead of 2/3. So that's it for this lesson. Thanks for watching.